Okay, Molar ratios lab. This is the post-lab content. And so you've completed your lab, and now we need to look at what you have and how you did. And so this is going to introduce some of the stoichiometry calculations that we're going to get accustomed to and used to doing in this class. And so what we're going to do is we're going to take your data. I have a set of data here that I took from some students, and it looks fairly good. Okay, it looks pretty good here, and so we've got it recorded with our silver wire, silver nitrate, and our copper wire, and so forth. And so let's find out what we do with these numbers. So on this page here, I've got my data table up the top, and I've got my balance equation that we did together in class. And so question number 1 says, calculate the mass and moles of copper wire that reacts in the experiment. So I'm going to take my grams here of the copper wire initially, and I'm going to subtract it from the ending mass there. And when I do that, I get 0.18. Now, the other information I need is that I need to know what the copper's AMU is, which is 63.55. So I'm going to take the 0.18 grams of copper, that's how much was used in the reaction I had, place it over 1, just like we've done before with our Star Trek stuff. I need to get rid of grams. Grams goes on the bottom, and that's where the 63.55 goes to 1 mole. And that's always going to be this grams to mole here. This equals this really small number because we didn't use that much copper. Then I need to repeat it with the silver. And so if everything went right, I've measured and I've got my 0.75 because I subtracted off my filter paper, and I produced 0.75. And I don't know if I did good or not. So here I am. I'm going to take my 0.75 grams of silver, and I'm going to get rid of the grams by putting the molar mass of silver on the bottom, the 107.87, and the 1 mole of Ag on top. And I produce this number here. Again, I'm not real sure if I did well on that. So now we said originally that based on our balance equation that it's a 2-to-1 ratio between the silver to the copper. So I'm going to take the moles that I got for the silver and divide it by the moles that I got for the copper. And what I'm going to find out is that this group here got a 2.45 ratio, and it asked me to round to the whole number. So that's 2 Ag to 1 copper, and that looks pretty good. All right. Question number 4. We've already done this. We've already written our equation. The only difference would be here if you produce a different number. Let's say you produce a 3, then we're asking you to put a 3 here in place of the 2 because that's your ratio that you produce. So question 5 says, did all the silver nitrate react in this experiment? So if you had a solution that was still cloudy or still whitish, then you might conclude that you didn't use all of your silver nitrate. But let's find out mathematically. So we're going to take that 0.8 grams of silver nitrate that I gave this team initially, and I'm going to convert it. And so when I get my molar mass of silver nitrate, it's going to add up to 169.87 when I add up all the parts that are in this equation. I'm going to take the 0.8 grams. I need to get rid of the grams, so grams goes on the bottom. That's where the 169.87 goes, 1 mole on top. Then I go back to my balance equation, and I have 2 moles of silver nitrate to 2 moles of silver. Okay. And so here I got my 2 moles of silver nitrate, and now I'm going to put 2 moles of silver. This is my step that allows me to go from one to the other. Then moles don't mean much to us, so moles on top, I'm going to put moles on bottom, and I'm putting the grams of silver on top. And I get 0.508, and that should be the max. That's also what we call our theoretical yield, which is a problem for this team because for some reason, this should be the maximum that they're able to produce, and yet they're saying they produce 0.75 grams. Okay? So then, question number 6 says, what factors account for the answer in number 5? So there's two things that will happen on here based on your data. If your data comes in underneath, like you have less silver than what was theoretically could be produced based on this calculation here. If you have less than this number, then that means not everything reacted. However, if you're producing a number greater than this number, you need to reflect. Where was there a place for an error? Maybe when you were getting the silver off of the copper, did some of the copper flake onto that silver and get placed in there for weighing? That could account for some of the mass being too large. Did we truly get only silver out on our filtration system, or is there maybe a little bit of copper in there too that's accounting for a little bit larger mass? Maybe we needed to change our technique so we could only get silver out. So just some thoughts there. Okay, pre-AP or honors. These are your questions. You're going to look up and find out what the market value of silver is, and then find out how much would we really make off this silver that we produce. As always, answer your standard 5 questions. A little bit more about this, just some extra notes. Molar ratio is something we're working on. We talked about this in class. We're using the coefficients out front, and that's how we get our molar ratio from one to the other. And then this is just a little chart showing you how we go from one to the other. Empirical formulas are our lowest, our smallest denominator when it comes to our compounds. So like hydrogen peroxide H2O2, that would just be HO for its empirical formula. All right. These are all terms you're going to be learning soon. Solubility rules, because you got to see that, you know, certain metals are soluble or insoluble. Pretty much when they tag onto a nitrate, they're always soluble. Again, the solubility rules, always soluble, NAGs, nitrates, acetates in group 1, and SAG, sulfates, ammonia in group 13. And then your exceptions. Review over your balancing equations, because we're still working on an equation work and which type of equation we talked about. This is a single replacement reaction. Okay. And again, we've already gone over these words, your subscript, coefficient, and your formula. Reactants, yields, products. Arrow means yield. And then our rules for balancing equations, we do metals first, followed by non-metals and polyatomics, and hydrogen oxygen last. And this is the end of your lab. I wish you the best, and great job this week. Live long and prosper.